Today on the bench I've got something for you audiophiles. It's a power regenerator. If you don't like how your mains comes in, try one of these. This unit's from PS Audio, made in America, and it's pretty heavy, quite compact from the front, but it's quite long. So if you're wondering what's wrong with normal grid electric, I'll show you. These are the mains. I've connected a little transformer straight to a plug, just to knock the voltage down to a manageable level for the equipment. Don't blow that up. Then it goes to the oscilloscope, and I'm also measuring the harmonic distortion on this audio analyzer. On the oscilloscope you can see this flat top waveform. That's very typical for the modern day. All the electronic power supplies, phone chargers, LED lights, your car that you're charging, these are all taking the electricity at the exact same instant, right at the peak of the waveform. It's not great. But 7.5% harmonic distortion, that's pretty ropey. PS Audio's solution's actually rather simple, if not a bit heavy. They're just generating a sinusoidal waveform using quite a simple circuit, and then just basically this is a big amplifier. It's a pretty simple affair from the front. Power switch, mode, frequency, and the little display. Rattling around in there. And the back's nice and funky. You've got 3 UK sockets on here. Rated for 500 watts apparently. So that's what, 2 amps over here. Also using audio type powered leads, of course. Typical of anything for me to look at, it's broken. So we can't play with it just yet. And this case is adorned with a fan and a, well, I'm not sure why that's not covered up. Interesting. Well, it won't on here not to turn it on for 2 hours after turning it off. Well, I'm not Electroboom, so this hasn't been on for 2 months. Safe to take the back off. Let's fit the right screwdriver bit in here, posi drive, and get these out. Well, there's a cooling fan sat there, with a bit of tagboard. Interesting mod. I wonder why they've done it like that. Oh, the fan's easily unplugged anyway. Just on this little connector here. Pull that out. We're away. Well, it looks pristine in here. Very nice. Not a bit of dust. Don't see any immediate damage anyway. I can't believe for a minute there's anything wrong with any of this magnetic stuff here. These transformers look very solid. And it's only 2 amps rated. Nah, bet these are fine. Should check the input fuse really. 3 amps. And it looks intact. However, it's actually 5 amps. Oh well done someone. Back in the business end, we can remove this signal generator board. This is our sine wave generator. Very analog it is. It's got a PIC microcontroller on there. It's a PIC 16C63. Oh, that's going back a bit. Looking at all the date codes on these components here, this is all looking, there's some from 1999, these I think is 2000, and this, yeah, this thing's 22 years old. Have this ribbon cable off. Just have a poke around, see if anything's gone on here. There's just rows of transistors at this side and this side, built very much like a conventional amplifier. Got some leads in there with a diode test. I think these are all bipolar transistors, no FETs in here. These all look okay, that one's good. Oh, there's a short. And the same readings here. Yeah, that one's short as well. Yeah, these two are short circuit. Well, I've seen enough to know I'm going to take the main board out, so might as well do that. Screws on the bottom. That reveals the offending items, all these transistors in here. We'll have a closer look at those in a moment. Just realised I've got to unplug all these cables, and perhaps I should have done that before I undid everything else. Although there are still some screws in, so I haven't goofed up. Some of these are rather tight, I tell you. Oh. The relay looks a little bit burnt there, doesn't it? Let's get these screws out now. Hope it just lifts out. Oh, not too bad at all. It's actually quite a nice looking board, I think. All the components on the one side, apart from one resistor. Yeah, not bad. I'm a little bit interested in this insulation. This is tape, Kapton tape. There's probably an audiophile reason for doing this, but I think it's just cheap and simple, which isn't a bad thing. Just never seen it done before. Yuck. Ugh. I can have a close look at these transistors now. Down here we've got a whole row of MJL 21194s. See if we've got any shorts. Oh, yeah, that's completely shorted. So's that. These are actually okay. That's got two at the top, two at the bottom. Or was that the bottom, that's the top? I don't know. So, these pair are shorted and these pair are. It's a good idea to remove any shorty components before I go any further diagnosing, because they'll throw the readings off. Just add a bit of solder to this just to sort of wet it. Because hopefully if I can just flood these, it might just drop out. Oh, there's such better ways of doing this. There, it's out. Hopefully this one goes a bit better. Just clean those holes up. These two opposite two, I think. Check they're shorted. Yes, they are. Yeah, we'll get those out as well. But from this way up, start the nearest one. I just measured these four and there's only two actually faulty. They're in parallel. I'll replace them anyway. Wouldn't have to check the rest of all these transistors in here. There's not that many really, and it's probably quicker than trying to work out how the circuit works. No problems there. Get the probe in there. Sometimes you have to dig the meter probe in a bit harder. Yeah, these are fine here. Okay, this one U1, it's not a transistor because the others are called Q. So this is probably some sort of regulator or something. But again, I doubt there's anything shorted on here. But we haven't got fuses blown either, so I'm not really expecting to find any shorts like that. Just spin it round and check from this side. Yeah, it looks all good there. And down this row as well. Base will be on the right hand side this time. Yeah, well, I've got this one. Finally this one here. Yeah, flip the board over to get to some of these others that I couldn't reach because they're buried and things in the way. So here, same story. Looking for the volt drop. Oh, so what we got now is about 0.096. That's going to be something like a 10 ohm resistor. And as long as it's on every one, which it is, yeah, we're happy. Yeah, I see no trouble there. Well, I'm not seeing any further damage on this, so I'm quite prepared just to put this back together with some new transistors. Oh, that relay. Let's have a look at that. Yeah, I think this relay switches the output on and off, and it's definitely had a bit of flash going on in there. You can see a bit of carbon in there, so it's probably a good idea to at least check it out. Or do I just replace it? I'll put some fresh solder on, like always. Seems to make it work a bit better. The desoldering, that is. See how the desoldering tool handles this. Hopefully the legs line up. Nice. We'll solder this straight in. One over there. Over there. So I've got these replacement transistors in. Just the thing. Quite well packaged, beautifully. They can't get in the box though. Well hidden. Beautifully packaged they are. I've got to bend the legs correctly. These were bent up, so I need a little bit of a jig. But look, I found this bit of oak that just happens to be perfect. So put this on there like that. Just bend them up. Easy. So put the two 1193s in. Bit of a jiggle. There's one. Solder that in. There's one there. Bit more forgiving now, I can do the centre pins. And this one here. Snip these legs. That's looking rather neat anyway. Now back in the chassis, you've got to clean this old crusty heatsink paste up. Some of it's still a little bit wet. It's definitely gone a bit crusty. Now's probably the best time to sort out that wonky front screen, whatever's going on there. Fetch this panel off. It appears it was held in with silicone originally. It's a good time to clean the front panel actually whilst the screen's off. Now that can go back on. This part at least is a nice easy fix. Well, whilst the rest of the world was using seal pads for heatsink insulators, PS Audio View's cut on tape. I shall do the same in an attempt to keep this factory correct. Not sure how much I need there, not this much. Just put the tape right over the backs of these, making sure that all the metallic parts are covered. Just press that down. Just trim off the excess. I'm going to use wider tape now for the main transistor bodies. Trim that up because some screws have to go in between these. And we'll try again for the other side, same results I'm looking for. Oh. That much. Try not to get air bubbles in it. So that's bound to be a problem for the thermal conductivity of this, which I've never seen it used because of its thermal conductivity. Bit of a new one on me, that is. Lovely, now to snot it up with the heatsink compound. After all that nice work we've done. And not to forget this thermal switch here. That one's a lot on. Now to get this in, you can sort of got to slide in diagonally. Be careful I don't wipe that heatsink stuff everywhere. Find the holes, the board. Yeah, like that I think. Some of those in first. Just loosely to begin with. Next, to fit these heatsink clamping bars, they've actually all got little rubber pads on that have set pretty hard, but I think they'll be okay. It's the same transistors going back, so it should be good. But it does need to go on its side. Try to line this up. That one's in okay. Looking good. And for this side, just check that the Captain tape is holding. Just connect to earth anywhere. We'll get a beep if we've got continuity. Just measure the centre pins of all these transistors, so we don't want any continuity to ground there. So I think that's a common thing. So you can plug these back in. 4-pin connector goes there. We've got this connector here with the one arm missing. That's because it's too close to the voltage selector switch. Make sure they're all solid. And here we got the multi-wave control board. must face the front panel. Let's not cock that up. Just slides in there. I think that's about it. I did find out that this is the factory installed Whisper fan module. Good to know. So it just plugs in down there. If you get the plug the right way around. There we go. That's it. Squeeze a few of these screws in. Finally put a 3 amp fuse in this. There we go. Give it some power. I'm also going to connect a light load, 15 watt bulb, just to check that we actually have some output from this at all. Pick a socket. Well, it's ready for the power on. Bit of inrush then, but no bang. It's drawing just over 1 amp. Let's give a 15 watt bulb output. Change the mode from 60 Hz, 55, 50. Wow. I'm not sure it's working right. It sometimes pulls a lot of current and makes a lot of noise. We get a bit of occasional erratic behaviour from this, and I think it might be these terminals. Look at these. They're pretty ropey. Yeah, so I'll clean those up. And back from the other bench, all cleaned up. See if that's any better. Doesn't look too bad at all. Tell me that's not a beautifully clean sine wave. Much better. There we've got 60 Hz, 55 and 50. 50 Hz is a bit more distorted, which according to this is about 2.5%. Much better. You're at the sort of technical level there, slagging off a sine wave. I think you'll agree that's a massive improvement on what we had before. No flat tops around here. Well, I'm calling that a success. If you want beautiful sine waves for your amp or whatever, probably want one of these. Catch you next time.